Morning, guys. We miss you. We hope you feel better. I'm making a recording of math class today. Everybody say hi, Clappy. Hi, Aiden. Hi. They're not watching, just recording. I am going to record math class today. I hope it helps. And then I will send you any information about class. But everyone's just getting in. This recording is going to sound bad right now. It will get better once everyone's not here. It's outside. Homework out. Warm-ups on the board. Take a look. See what you know.
Okay, I was like, is she tricking me? And I don't think it's really good.
Yeah, it was just writing four numbers.
Wait, other than 6.
Oh, that's weird.
I think, or maybe this is that one. Wait, which one? The back side on the left.
I think
Which one?
I agree.
Like 11, 13, 14, 17.
Fine, homework out.
Okay.
You got to a little bit move it. You
So
got
the
to
white
a little bit move it.
I still, I only know. No. Please no.
I didn't even look at that. I didn't even realize
No.
that. They all do that. I just wrote down whatever. I was really confused.
Yeah, she had Maya sent me a message and she was like, I don't know how to do the windows. And I have a lesson about how to set windows up. And I think the windows like, how do you make a window big enough?
I couldn't figure it out. I still I want to Oh, why you just know why that's what I did.
Oh,
Yeah, it doesn't work. Yeah. No, it's like, yeah, I didn't know what to check. I just keep it.
You know.
So, please have a seat. I'm not changing seats right now, and because I'm short people. Will, why don't you sit over where Aiden usually sits because he's not here? Cooper, why don't you sit over where Chloe usually sits because she's not here and you can see better, please. You can leave leave your binder on the left over there. You've got extra room now. Yeah, there you go. That way you're not in Quinn's space. Okay, so you got that to do the page. Okay, it was and the page was exactly what we had done in class, but we'll talk about that in a minute. Okay, so right up here, first let's talk about labeling what we know. I have y equals mx plus b, and I have y equals ax squared plus bx plus c. This is what kind of equation? This is what kind of equation?
Linear.
This is what kind of equation, Will?
Linear.
What kind of equation is this one? And it's y equals ax squared plus bx plus c. This is not the only way you can see these equations, but this is standard form. Quinn?
Was number 6 a linear equation?
I gotta look at it. I think I gave away my extra. Number 6 was not linear because it has a squared. Okay, so that means that it just never crosses this. So if I were to draw that one, 6 would have looked like this. Okay. So there are going to be different, so if you ever have, it's all about the variable. That's a great question. The reason why I know this is going to be linear, this one, is because the highest power I have in this one is 1, which means it has one direction. On this one, the highest power I have is squared, which means the graph is going to have 2 directions. If I saw this one, how many directions will that have? 4. So that means if I were to graph it, it would look like this. 1, 2, 3, 4. If I were to have this, how many directions? 7. It would go 1, 2, 3, 4, 5, 6, 7. We're not going to deal with those. But the power determines how many directions it has. So that's how you'll always know. So if you ever see an x squared in a problem, it is always a quadratic. Okay, I think I'm going to turn on the lights because I think
Yeah, let me do it for you.
since you're going that way. Yeah, I think that's better. Okay, maybe not this one. I'm trying to make it so that it's not so glary on here. It's a little bit, no, that's worse. I don't know. Okay, the whiteboards aren't forgiving with glare. Okay, so what do we know here? Tell me something we know in this equation. It's linear. What else do we know?
It's going up.
Well, we don't. Well, we do know it's going up because m is positive technically there, right? But what is m? What else is m? 1. What else is M? Slope. M is slope. So this is always your slope, right? What is B?
But the y-intercept.
The y-intercept, always, right? So we know that right away. It's what we can see without looking at the equation. If I know those two pieces on a linear graph, I can graph it. That is all I need to know. I only need those two things. When you were in Jason's math class, he had you create a table, plug in 3 numbers or 5 numbers, and graph it, right?
Yes.
You come to my class and I go, oh, you don't need to do that. All the information's right there. I look at it and go, B says 7. I go on the y-axis, mark that point, and then I go over and up based on what the slope tells me. I can only do it if the y is alone.
So what's the whole point of learning the first way anyway?
So that you know how to do basic math skills. The next one, what do I know from this one? What are some things I can tell from this one? What do those letters show you? Remember I was showing you when I was home that video where I played with the A, B, and C? You tell me one. What does C do?
C is like the y.
C is always the y-intercept. Okay, C is your y-intercept. It tells you where the thing's going to cross the y. It doesn't necessarily mean that the lowest, the vertex, is going to be on it, but it means that wherever it crosses, you know one point of the graph. What else do we know? Yes? Tell me what you're thinking.
I don't know what I'm thinking. Is B the slope?
B is not the slope, but that's okay. If you remember when I played with B on the thing on the line, it moved it like this. It was either here, 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 so it moves it left or right, which kind of is like slope. But it's moving, it's the direction. So this one's going to move it that way, pretty much. A little bit this way too. And we'll get into knowing what that means. What does this one tell us?
Wait, what if it's like super far over and it doesn't have and it doesn't have a y-intercept?
Excellent. We won't have to worry about that. That's when we get into imaginary numbers, and that's going to be math too.
Ow!
Because imaginary numbers are complex. Yes.
Does it say what tells you whether it's like up or
Yeah, this tells you up or down. That's what Will was going to say, right?
Yes.
It also determines the width. If the number is really big, it's going to be really skinny. If there's 100 in front of it, it's going to make it really skinny because it's going to be increasing very quickly. And if the number is really tiny, like 1/8, it's going to make it wider. So that number gets impacted this way. Because if you think about it, as I get to 0, it's a straight line, right? And then I go 1, 2, 3, 4, 5, 6. It keeps getting more. So that's what happens to it. It makes it go up and down. When we look here, I have this equation, 4x plus 3, and I have this equation, 2x plus 4x plus 3.
they're the same?
What's the same?
The 4x plus 3.
The 4x plus 3, so they have this in common. What else do they have in common? What else do they have in common?
The y-intercept.
The y-intercept. So this is definitely the same. I didn't do very well drawing it, but it's supposed to be going through the same spot. Okay, so they both cross the y-axis at that one point. What's another thing that they kind of seem to have in similar? Yeah.
They both have a y.
They both have a y. What do you mean by y? They have lots of y's.
They have a y, right? Y equals.
Oh, they both have this, the way they're set up. They're both in standard format. That's what I would say mathematically. Are they both positive? Yeah, they're both positive because this is going this way and this is going, this one's going this way and this one's going this way. I just wanted to show you the few things that we can see just by looking at this equation. I graphed it right away. When I looked at this equation, I couldn't graph it right away. All I could do was mark 3 and I knew it opened up. There are other things I need to know, like I need to know where the lowest point is in order to graph that. Yes?
So when you look at those tortuous equations, how do you know what they're supposed to, the graph, the line, how do you know what they're supposed to look like?
The only thing I know from looking at this is that it's going to cross the y-axis. So if I were to graph this one on my own, like if I had this, I know that there's going to be a point at 0, 3, because that's my y-intercept. I know it opens up, but I can't graph it any more than that without doing a little math. This one, I know it crosses at 3. I know my slope is what? So that means I go over 1, up 4.
Oh,
Over 1, up 4. There you go, I'm graphed. So I can graph a linear without doing any math. This one, today, I'm going to show you the other piece of what you need to know to graph it without doing too much math. Okay?
Is it short?
Without doing a table and
Just
plugging in 12 numbers. Okay, so it's kind of a shortcut, yes. It's understanding what you can pull out of something to get something else out of it. Okay, let me erase this. Let's go to the homework super fast. We're going to start with the book homework. That was more challenging. And then we're going to go to the worksheet. The worksheet's going to lead into the notes I want to give you. Okay? So the homework last night was, of course I put, hi guys. How you doing? Everything good? Yay. Wouldn't you guys be excited to get a video from me if you were homesick all day and you could wake up and I'd be there and I could sing to you? I'm sending it to Aiden. Right, Aiden? Hi, Aiden. I know, I didn't think about it until. So what page was your homework? 468?
No.
No, it was 481.
481, it was 481. 481, number 5. It was about the bridge again. And this time we have a bridge and the function is y equals 0.004x squared plus or minus x plus 80. This was representing one of these suspension bridges again, like that. Okay, and the first question is, what is the approximate height from the bridge of each tower for which the cable is suspended? So here we have this, and this is supposed to be, the bridge is there, but this is supposed to be representing your coordinate plane. This is your x, this is your y. Here's your bridge. Okay, what's my y-intercept?
80.
80. So if my y-intercept is 80, that means that the height of the towers are 80, right?
Yeah.
I know this is 0, 80. I know this is something 80. Okay, so my height A is 80. Okay, that was the easy one, right?
Yes.
The next one got a little trickier, not because you guys probably didn't understand it, but maybe the window part.
Wait, that was the answer?
Yep.
Yeah. Wait, what? How did you?
So that's why you read my you didn't have to do any math on that one.
Oh,
That was all the question of what can you determine from a first glance?
What was I doing?
You were thinking you had to do math.
No, I like was so lost.
So then the second question is, what, let me adjust right in black. What is the shortest distance from the cable to the bridge service? This is your cable, and this is your bridge service. They want to know what's the shortest distance right here. Okay, so it's the one in the middle. So you could say in the middle, but how do we find that actually out? Yes. You can plug it into your calculator. I'm going to show you a way to do it mathematically today. So if your calculator freaks you out, and some of you it does, when I went to college, my senior year, I went to a small high school. I went to a high school with 200 kids. I had calculus, we didn't use calculators, we used all old school. I used like a basic calculator, like, you know, for that kind of stuff. Otherwise, I did everything by hand. I went to college, and that was the year that, like, when I went to college, my senior year of college was the first email I ever sent. So I didn't use email my freshman year. My senior year, the first time I sent an email, it was to my friend 2 seats away from me, and I thought it was amazing. I was like, she just got a message I sent her, and she's over there. So that's where my technology was when I was in school. When I got to college my freshman year, we had to use the calculator. I would get points taken off because I didn't know how to use my calculator. It was too many buttons, and I know how to do everything by hand. I will tell you, it's good to know how to do things by hand for when the calculator throws you off. Okay, so you put it into the graph, you plug this in, y equals, and you plug in this equation, and then you're going to go to, you want to find the maximum or minimum. It's tricky because when you first plug this in, a lot of you probably saw something like this, maybe you saw just a piece of something. I don't know which way it would have looked.
No, it didn't show anything.
Or you just saw this part. You know, you might not have seen anything. So the thing is you have to know by looking at this what window is going to work. Question marks, his ears. Okay, so what window is going to work? Okay, so for the window, we want to think about, first off, do I know what my maximum Y is going to be that I care about?
No.
What's the height of the towers? 80. So what's my Y window need to be? 0 to 80 or 90? Yeah, so there you go. So right away I look at this and I go, well, I know it's got to be, I got X min, X max, Y min, Y max. I know right away I want my Y minimum to be 0, and I know my max could be 90. I can go a little over that 80. So whatever your C is, you want your Y max to be a little bigger. Yes.
Me?
Will.
Wait, how do you like get to the next?
Oh, window.
Window.
You're gonna hit window on your calculator.
Yeah.
Do you have a calculator with you? Bring yours.
Oh, wait, that's right.
It's on the floor for a week.
Wait, 90.
Yes.
That was 8.
We were just saying if you do a little extra window, it's sometimes a good idea.
It was hard to tell this the number from the middle of the line, so I couldn't tell.
So you might be in between, as long as you're kind of close. So then you want to do your Y minimum and maximum. So here I am looking at it going, I don't know what to do for that, but it's a bridge. And so I could think about a bridge, and I go, you know what, I'm going to start with 0 for my minimum, because I know that I want to start at the bottom here. This is where my bridge line is. And let me go up to 200 and just see what that does. 200 might not be big enough, but it might be.
I don't think I can keep it as that.
You might end up needing to go a little bit further. You did 500? 500 is good. Did 500 work? So she did 500. That might be a good bridge number.
So you just,
I guess but I thought about it. I thought about it's a bridge. A bridge is an educated best. About how long would a bridge be? And what we're learning is bridges are about 300 feet, 400 feet across. Well, just from looking at this, because the first equation that we did the other day, it was 300 feet, something like that.
Oh, wait. The X thing is like how wide you're seeing.
Yep. And the Y is how tall.
Oh.
Kashan.
Oh my God, that's so cool.
That's it. That's good.
Like, then it's my set 0.
Does it what?
Oh yeah.
Okay, so then you go to trace. So to get to trace, you have to hit second calc. Yes.
Oh yeah, the minimum stuff.
Okay, Lisa.
The minimum is, if you're thinking, if whenever we're dealing with bridges, the minimum is how low can it be? So Maya?
Yes.
So this is my x-axis and this is my y-axis, right? At this point, my y is 0. That's the lowest I want to look at, right?
That was your X.
This is my x-axis, but on my x-axis, y equals 0. Y is 0 here. X is lots of numbers, but y is 0.
Oh, because this is super low. Okay.
And then up here, this line, my x is 0.
That is a dirty error.
Yeah.
After you go to second.
It's just
Okay.
You're going to go to, now that we know it goes this way, you're going to go to minimum.
So it's like 0.
Okay, minimum, then you hit left bound, right bound.
For some reason, when I type in the exact equation, it shows a linear equation.
Your window's not big enough.
No, it's still a linear equation.
You probably didn't put in square.
I put
You did something.
0.0.
Or you don't have your calculators.
X. I think it doesn't mean there's no matter.
You don't have a big enough window. You're on the y-axis right now. You want to make your x, go to your window.
No,
And change your window to, yeah, x minimum needs to be 0, x maximum needs to be 90. Y minimum needs to be 0, y maximum should be about 500.
So you got a minimum, which we already did. You're right.
Okay, so then you want to left bound, which means this way. So move your little guy
Oh
over.
my God, we can move the flower away.
And then press enter. Now it says right down.
Definitely a linear.
You go over
Yeah,
here.
that's giving me a seizure. I
And
don't
then
know.
it says, do you want me to guess? And you say, yeah, I want you to guess.
Oh, for the
Oh, he's
middle
guessing.
point.
Yeah,
Yeah.
minimum is to those.
Oh,
Oh my God,
that is
that's so
crazy. That was all.
No, that was
Squared
So wait, it's
minus
just,
x
I don't know.
plus
X.
x. So I'm gonna
So
go down and
minimum
make
is
sure
like-
this is set right
No,
here.
no, no.
X.
Wait,
There you go. So then you
It
go.
already, that's the guess.
So
right
it's
there.
second count.
do that. How do you
And we want to get that out. This is left
And
bound,
you
so
just
you go all the way
scroll
over to the
over.
left.
Yeah, how do you
Enter.
click trace?
Same for both of them. I don't know. Is that what you press? You were holding a calculator.
How do I do what?
Oh shoot!
Oh my, are you
Second. Count.
I already did it.
Three. Now, this is left bound, so go a little bit over to the left.
I
So you
got
did.
it. Yes.
Just a little bit. There you
Right
go.
there, and then enter. Like that, yeah.
Oh,
bend it.
okay.
Oh,
Yeah,
yeah.
you got left down, press enter.
Oh, yeah, right there.
You go over to
Wait,
the.
does
Oh,
it
yes.
matter?
Wait, no, no.
I don't know what. That's like,
It doesn't matter. Oh, it
No,
tells you.
wait,
it
what?
says left.
What did I do?
Right
Oh,
down,
my
says
God,
yes.
are you serious? What did
Try
I
it again,
do?
just like higher. Okay, so you hit second down. And then you go to three. And then you go
Yes.
left bound. See, it says left bound. Enter. Right bound.
It's like a battle royale.
Yes.
Look what you did.
Okay, hit second pound.
I was really.
It's
So the three.
It's definitely from the negative.
My calculator
That's
says
the
like
thing.
that's
So
it.
you gotta go over, you're a little bit left of the bottom of your part. Yeah, now go over to the right bound.
Here, wait, wait, okay, okay. So look, yeah, yeah, yeah. And, oh my, what you
Yeah, you're
No, no, no.
Okay, once you get to that, guess.
Okay.
Wait,
Wait,
No, no, you have to just try.
I know, no, no, no. Here, then. Oh, yeah, I did the, oh, yeah, I did.
Okay, so when you get to the guess, guys, you get this. You get x equals.
Well, look here.
So you have no legs.
I am at legs. That's
If you can hear my voice, I can hear your voice. Okay, so once you get left, right, then you say guess. The guess is the height. I put x here, but I should put h for height. We have an x value, which tells you this. This is your x value. This is your y value we're looking for. What was the y value at that guessing point? 17.5. It's about 17.5 inches. Feet. Inches would be really low.
Oh, so you only look for Y.
Yeah, because we're looking for height. Y is height, x is length. Okay, distance. The last one says then, once you go left bound, hit enter, you go right bound, hit enter, and then it will say guess, and you hit enter.
Oh, that's.
So then the next thing is that you're looking for when is the inequality, when is the cable greater than 50 feet? They want to know when is this line 50, when is it here?
When Y is.
So when is, well, they want to know what is x when y is 50 or greater.
How do you put, you say you put.
Pardon, I have two of you asking the question.
How do I write that? So like right inequality.
Right inequality, oh, so let's look at that in a second. So they want to know when is x, what values of x make it the cable greater than 50 feet? Question.
So you put in 50 and a Y. And then
No, what you're going to do is, well, I'm just showing you so you can see this visually. You just do trace. Trace, so I would go trace and I would go all the way back to it and I'd look for when is y 50? What is the value of x when y is 50? It's going to happen twice.
When is Y 50?
Yep.
What if you can't get it to exact?
It might not be exact, close. Close, you could just go close.
32.8.
So we have when x is, so from when x is 0 to 32.5, right? And then what's the next one? When does it happen again?
218. No, I found it. No, I found it.
What's that? Huh?
Around 282.
How did you do that? So you go like this. This is why I don't want calculators. It takes so much time. You just go trace.
How do you know
can
what
see?
Does it matter?
You gotta do both sides. To see how it's like 48 here, so it's 212. 218, so it's around 218. So 218 and greater.
Yeah, so it's like
Right?
34.
And then I want to go back this way.
Wait, how do you
I'm
know
gonna watch
you
the one
always
this
get
turns
Y?
50. So that's about 50, so it's about 31 or between 31 and 37. Okay, when x is 31 and 37. Yes.
So you could go this way or you could go that way. So
You
how
gotta
do you
do both. They
Oh,
want to
it's
go
an
both.
average.
They want to do both. No, you're not finding an average. They want to know both windows.
Oh, okay.
Both times.
So this is 34 and that's like 2.
Yep, so it's gonna be when x is less than. So if you think about it,
Here, 50.
so when x is less than 32.5, right? So I can do it this way. No, x, or when it's less than 218. That's your inequality, but that's a weird way to write it. We don't usually write them that way. X has to be less than 32.5, or x has to be greater than, I guess it's the opposite. I do it backwards, greater than 218.
Yeah, I think so.
Yeah, see, I can't do a double like that. That makes me confused. 0 has to be less than x, has to be less than 32.5, and then x has to be greater than 218. 5 to 2 times. Yeah, they wrote it like this. Let's see how they wrote it. They wrote it just like I wrote it.
How do you?
They wrote it this way though. They went 218 has to be just less than 250. I guess the bridge was 250 total. And I don't know how you know that, but don't worry about that. Let's move on. Calculator, we'll keep practicing. I want you to understand how to do this by hand. It will make things a lot easier. You won't be so worried about the windows, max, minimum, all that stuff if I get off of the things. Where's the pen? I don't think I can do that. Yeah, go grab one from the dirty even. It's okay. Okay, so what we're going to move into is talking about coefficients and coefficients direction. We're going to look at that and we're going to take a few notes. Oh no, I forgot. I had my notes. Yeah. Oh my gosh, honey, we're not having a lesson test until next week, but we're going to finish this unit before. I'm going to show you right now how to do this mathematically, and a lot of you are going to go, this is easier. A lot of you think at first you're like, oh, we get calculators. Calculators will be the easiest way to do things, and it's really not true.